Entities and tables may be used interchangeably. However, we can differentiate these terms using the logical data model and the physical data model. Amazon Web Services provides a clear difference. In logical design, when you are gathering ideas on how to solve problems, mostly business problems, we use the term entities. When we start creating databases in a physical model, we convert entities into tables. For more information, type this link in your browser. The link is also available in the PowerPoint. A database system is developed to respond to the business problems. As a result, the business rules guide the creation of a database by defining entities, attributes, relationships, and constraints. For example, we want to create a database that allows a customer to generate many invoices. This is a clear business rule. However, allowing a customer to return products at any time is not a business rule because any time is not a clear term. Any time may mean a day, a week, a month, a year, a decade, and so on. Constraints help data integrity by providing a clear definition of data. For example, if we are creating a database that generates the GPA for students, it is recommended to provide the limits for GPA. In the United States, GPA is always between 0 and 4, which means that we must validate the user input to be decimal numbers between 0 and 4. Business rules are generally documented as company procedures, which may be updated to reflect the institution's goals and plans. The high-level administration, such as managers, policymakers, and department managers, set the business rules. Business rules are crucial to ensure the standardization of companies' data. For example, the GPA between 0 and 4 must be applied to in-person and distance students in the United States and overseas. Business rules are also a good communication tool between users and designers. This means that the users and the designers must agree on the implementation of business rule in designing databases. For example, users cannot complain that they cannot enter the decimal numbers greater than 4 as a GPA. Business rules help designers to understand business process. Business rules also clarify format of data and relationships between entities. You must know these basic definitions. An entity is a person, place, things, concept, or event about which data will be collected and stored. An attribute is a characteristic of an entity. Finally, a relationship describes an association among entities. In this chapter, we are going to focus on 3 relationships. One to many. As you can see here, we have one. M is for many, so this is one notation. We have also the second notation. The second relationship is many to many, so represented by M colon N, and also we have this notation. Then we have one to one. We have the first notation, and also we have the second notation. I'm going to provide examples for one-to-many relationship. For example, you can say one director supervises many employees. So we have one director to many employees. For many-to-many, we have many students take many courses. Then for one-to-one, an example will be an employee belongs to one department. Once the database design team understands the business rule, they create data models. The most common model is the entity relationship model that shows the entities, attributes, and their relationships. We have three notations, and you must be familiar with these three notations. We have chain notation, we have closed foot notation, then we have the class diagram notation, which is part of the Unified Modeling Language, or UML. These are the examples. So for the chain notation, this is the representation of an entity, a rectangle. This is like a painter. So this is the relationship between these two entities. Then we have what we call the cardinality. So we have one painter paints many paintings. So this is one to many. Same representation. So this is an entity, employee. We have skill. This is the second entity. The relationship will be employee learns many skills. So the relationship will be M to N. This is one-to-one relationship. So we have one employee manages one store. So it's one-to-one. So this will be the chain notation. Then we have closed foot notation. This will be a painter. So this is an entity. This is how we're going to represent the relationship. So this is one to many. And this is will be many to many. So as you can see here, so this is many. So I want to do it here twice. Then this is how we represent one. This is one to one. And this is going to be UML, class diagram notation. So this is an entity, an entity. This will be the relationship. This is one to many. This is many to many. And this is one to one. So there are challenges, some challenges when it comes to many relationships. This is an example from IBM related to the creation of a database for the telephone directory. So we have two tables. Here we have the tables for the employees, like the employees. Then here we have the information for the fax. Based on this based on this entity relationship diagram, we can see here we have the name. So this is the relationship is going to be zero or many. Then here on the other side, we have many. So it means one person can have zero or one or many fax numbers. So a problem exists in the fax entity because the telephone number is a primary key that can appear more than one time in the fax entity. So to solve this problem, we create the third table we called intersect entity. And the third table is going to be generally composed by two primary keys from two tables. You can see this is the primary key from this table, and this is the primary key from the second table. So many-to-many relationship may provide a challenge. That is why some database designers prefer breaking many-to-many into two one-to-many relationship, but it's going to be based on the business question. So for here, we're going to focus on the close foot notation. So a ring represents 0, as you can see here. A dash represents 1, and this symbol represents many or infinite. The reference will be here on this link. So sometimes we wanted to provide the cardinality, the minimum and the maximum. So this is going to be minimum 0, maximum 1. This is going to be minimum 1 and maximum 1. This is going to be minimum 0 and maximum many. This is going to be minimum 1, maximum many. So this is going to be 1, many. This is going to be 0, many. This is going to be 1, 1, and this is going to be 0, 1. For example, if we take the previous example about fax and employee, so an employee can have 0, 1, or many fax number. So that's why by going back to this link, we can see here, so we have an employee can have 0, 1, or many fax number. That's why we have this link. While here for when we created the relationship between a fax and the employee, so a fax can be assigned to 1 employee or to many. Okay, so for this slide, we have two tables. The first table is agent, the second table is customer. The question is, how do we link two tables? We can use a primary key of a table as a foreign key in another table. So table agent has 6 fields. So we have this one, field 1, 2, 3, 4, 5, and 6. Customer table has 10 fields. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that the last field is the same as the first field in this table. You can see that the first customer with the customer code 110, this is the first customer, will be served by agent whose agent code is 502. The same agent will also serve customers 112, 113, as well as 116. The relationship between these two tables is going to be 1M, which means one agent can serve many customers. And these two tables are linked through this field agent code, which is a primary key here in the agent table. And this field is in another table, so it's going to be a foreign key. It's going to be considered as a foreign key, but in this table, it's considered as a primary key. After creating the two tables, we can check the relationship, which shows here. So 1 is close to this table, which is agent. Then infinity represents many. Internet of Things, called also IoT, are generally embedded devices with sensors, software, and other technologies to connect and exchange data with other devices and systems over the internet. That's the definition from Oracle. We have the examples of the Internet of Things, such as smartwatches, and also, for example, the latest cars are equipped with the embedded devices with the Internet of Things. Relational databases deal with data organized in tables, and we can create relational databases using software, including SQL. Big data uses big data analytics to analyze big data from Internet of Things. This last slide shows some examples of big data technologies. It's crucial to highlight that SQL is used in relational databases and not in big data. So that's why here on this slide, we have no SQL.